So in this video, I would like to explain the different important parts of a slotting machine. This photo shows the column of the machine. This is a vertical column of the machine, and it consists of a guideway in front of this column. That is for mounting this vertical ram. So vertical ram can freely move in the slide from up and down, and all the mechanism, driving mechanism, and the automatic feeding mechanisms are incorporated in this column. So it is actually the structure of the machine. Is a RAM. RAM is also an important component which reciprocates. This is the front view of the RAM, so it reciprocates in the guideways of the column. And here at the bottom end you can see the tool head, and the tool is connected here. This is the table, a round table you can see here with the T slots. So the workpiece or the job can be held here on this top, and we can have three different directional movement is possible for this table. That means longitudinal feed, cross feed, and rotation of the table. All three movements are possible. Saddle is actually at the top of the bed of the machine. So on the saddle, the cross slide is there. On the cross slide, you can see the round table. So that saddle we can move the saddle for getting the longitudinal feed, and cross slide is used for getting cross feed, and there is another movement, that is the rotation of the round table. Tool head is fixed at the end of the ram, at the bottom end of the ram, and it carries tool post. And tool head is we cannot swivel the tool head. It is fixed. That means the tool head is having only a vertical slide only. That means vertical sliding movement is possible only. The no swiveling is possible for this slotting machine. So these are some of the specification of the slotting machine. So slotting machine is normally specified by its maximum length of the stroke of the ram. So maximum and minimum stroke, available stroke. Then the diameter of the work table. That means based on the diameter of the work table, we can machine that much size of the workpiece. And another one is the type of drive. That means quick return mechanism is important for the quick return movement of the RAM, and we can have different mechanism like the slotting mechanism, that is crank and slotting mechanism. Then by using sliding disc mechanism, that is the slotted disc mechanism. Then one more thing is the hydraulic mechanism. Then by using this speed motor, that means reverse motor can also be used for this mechanism. So these are some of the specification of the machine. So now we'll see the driving mechanism of the slaughter machine. The slotting machine produces flat surface, vertical surfaces. Then the ram holding the tool reciprocates vertically up and down. So that is actually the driving motion. Then it cuts the material only in the downward stroke. There should be some mechanism to move the ram in the reciprocating motion, and also the forward stroke, that cutting stroke, should be slow, and the return stroke should be fast. And that is actually the quick return mechanism. The mechanism is commonly, it uses slotted link mechanism, slotted disc mechanism, and crank and slotted link mechanism which we use in the shaper machine can also be used here. So now we'll see the simple mechanism of the slotted disc mechanism. It consists of two meshing gears. That is, one is smaller gear that is known as pinion, and this shaft, that is the pinion shaft, is connected to the driver motor here. So this rotation of the pinion will be transferred to this bull gear. This is the larger gear, so that the speed of rotation will be reduced. So from this bull gear, it is transferred to the driving disc. Driving disc. This is one of the important element of this mechanism. Driving disc, and when this is like a cam. This is like a cam, and one end it is eccentric. One end is connected to the one end of this driving disc is connected with the connecting rod, and the other end of the connecting rod is connected to the ram. And this ram is in a dovetail joint, or you can see that is the dovetail groove provided in the column of the machine. So this ram can move freely up and down. So this connecting rod will pull and push. That means it will move the ram in the top and bottom directions. So how it is possible? Because of this eccentricity, that means here you can see it is coupled in one end of the disc, and it is rotating like this, like what we are in our IC engine. We can convert this rotary movement into a sliding movement of the piston. The same process here also. This rotary movement of the motor, or this shaft, is has been converted into a translatory motion by using this driving disc and connecting rod, so that when it moves like this and when it goes here, that means now the connecting rod, this end is in the bottom level. So when it rotates, sometimes it goes to this position here. That means then this connecting rod will push down the ram, so the ram moves downwards. So this is the reciprocating movement is possible for the ram, because it is housed in a dovetail joint, so that the vertical movement is only allowed because of that speciality of that particular joint, that groove, and the inclined movement or the rotation will be restricted. Now we'll see the quick return mechanism. A mechanism makes the ram to move slowly during the cutting stroke, and during the return stroke, ram moves at a faster rate. To reduce the idle time, it should return very quickly. The mechanism adopted is known as quick return mechanism. Quick return mechanism. We'll see the quick return mechanism here. This is the mechanism slide, the slotted link crank and slotted link mechanism, which we are using in the shaper machine. Here you can see this figure shows the crank. This is the crank, and this is the slider, and this is connected to the slider is connected to a ram, the rocker arm, and when the crank rotates, the slider slides on this rocker arm, and because of this movement, and the connecting rod is also connected here. So when the connecting rod rotates, the ram rocks like this to and fro. This is the slaughter leg that is actually connected to the ram of the machine. So while moving, for example, suppose the this is the direction of the rotation of the this crank. So here you can see the position of the sliding block here. Now it is here. So while rotating the crank in this direction, the uh, ram moves in this direction. That is the rightward direction. That is the forward direction. That is the cutting stroke. So the slide, this pin traces this path like this, so that this end of the rocker arm or slaughter link pushes the ram and rams forward. That is the cutting stroke. So when it reaches here, here up to here, that will be moving in the forward stroke. So when it reaches here, it is that means this slotted link returns back. That means from here to here it returns back. That means less than 180 degree takes on for return. So because of the arc length is smaller compared to the arc length of the forward stroke, this has to move very fast. So that is why the return of the slaughter link will be very fast compared to the forward stroke. So you can see here theta 1 and theta 2. Theta 2 is lesser than theta 1. So as it is lesser amount or quantity, the angle, so it has to as the crank is rotating in the same speed, crank rotation is same speed, the motor speed is same, but it has to cover a larger distance here. Arc length is more, so it will be moving very slowly. Here it is it has to move very faster. That means the slaughter link has to move very fast. So that is why we are getting the quick return movement. Here also the same mechanism. In slaughter, the rotary movement of the electric motor and the bull gear will be converted into a reciprocating motion of the ram. Moreover, the return stroke will be faster than the forward stroke. So here it is explained very clearly. You can see this is the ram, vertical ram, and this is the connector node which is connected to the ram, and this is the crank plate or slotted link. You can see this is the slotted link or crank plate, in which there is a crank pin here. A crank pin is here, and when this one is rotated, and this one is rotated,